And in this video, we're going to go through the last 3 questions of this practice paper. First question here is vectors, lines, and planes. In video 1, we went through vectors algebra. So here we will do the second vectors question. You have a plane P, and on the plane P, you have point A, point B, and point C. 3 points, please find the Cartesian equation of the plane. So to find equation of the plane, there are 3 forms. We will use the first form first, which is the vector equation form. So plane R equals to known point 0, 1, 1 plus S, a direction vector. So we can choose any of these 2 points to interact with each other and just subtract them, right? So we will get 2 minus 2, 3 plus another direction vector, because for plane you need 2 direction vectors to describe it. The other one, let's just use this and the first one. So you get 0 minus negative 2, 2, 1 minus negative 1, 2, 1 minus 0, 1. And then what we do now is to find the normal so that we can use the R dot n equals to A dot n, which is called the scalar product form. So to find normal, you just need to cross these two. Normal would be 2, negative 2, 3, cross 2, 2, 1, first number, negative 2, minus 6, negative 8, second number, 2, minus 6, negative 4, so it becomes 4. Last number, 2 times 2, 4, 4 minus 4, 8. Simplifying this, you can use normal to be negative 2, 1, 2. To get to the R dot n equals to A dot n form, you just need to throw in the normal, negative 2, 1, 2, and then we will throw in a known point. The easiest one to do is 0, 1, 1 dot our normal again, 1, 3. So the correct answer is R dot negative 2, 1, 2 equals 3. Converting this into Cartesian form will be negative 2x plus y plus 2z equals to 3. Is that what they want? Oh, they divided throughout by negative 1. Divide throughout by negative 1, you will get this. 2x minus y minus 2z equals to negative 3. Shown. Next question, we need to show the acute angle between L and P. So L is this line, and then you have the plane. So it look like that, a plane, and then you have the line L. What angle does it meet the plane at? So to do this, remember the direction vector of the line is 1, 0, negative 2. The normal vector of the plane is negative 2, 1, 2. So if there are different species, meaning a line and plane, there are 3 interactions in total, right? Plane meeting a plane, and then there's an angle. And then you have plane and line, and finally you have line and line. There's an angle. Each of these has their own angles. So if they are the same species, use cosine. If they are the different species, use sine. What I mean is this. Just dot the direction vector and the normal vector. 1, 0, negative 2, dot, negative 2, 1, 2. This would be equals to 1, 0, negative 2, negative 2, 1, 2, cosine theta. If you use the dot product extension, you should get modulus of the first one, modulus of the second one, cosine the angle between them. But because they are different species, all you need to do is you throw this below here. And then you just equate this to sine theta instead. Now the explanation is rather simple, because if you were to find this with this, what you are finding is actually this angle here. This angle, yes, to find this, you use cosine theta. But we are not interested in this angle. We want the angle between the green color line and the blue color plane. So what you should be finding is this angle here. To find this angle, we can either use cosine, and then once you get this answer, we do a 90 minus whatever this is. Or simply just use sine from the beginning. Then you straight away find this angle. To simplify this, number on top, don't forget to modulus the whole thing, because they want the acute angle. The top would just be negative 2 minus 4, which is minus 6. Below you get square root 5 square root 9 equals to sine theta. So therefore, theta is equals to sine inverse. Don't forget to mod this, sine inverse Negative 6 over root 45. Press calculator, you will get 63.4 degrees. And we are done with the second part of this question. Third part is just 1 mark. Show that a point 5, negative 1, 2. So Q has the coordinates 5, negative 1, negative 2. Okay, but if they ask you for vector OQ, then you have to write it in vector form, which is like that. Position vector of Q is 5, negative 1, negative 2. But if they ask you for coordinates of Q, you use this one. Show that Q lies on line L. You put it into the line equation. If it lies on the line, this is a point not lying on the line. This is a point lying on the line. So if your point lies on the line, then you will be able to find a consistent lambda. What I mean is this. If you try to equate 5, negative 1, negative 2, if your point lies on the line, then you will be able to find a particular consistent lambda. If you compare the first row, what should lambda be? Lambda should be 3, right? If lambda is 3 and it satisfies all 3 coordinates, all 3, then we can conclude that Q lies on the line. So lambda is 3, right, for the first one. If lambda is 3 for the second one, it works. What about the last one? 4 plus, I missed out on negative 2. So does it work? Negative 2 equals to 4 plus negative 6. Yeah, it works. So this means that we can find a lambda equals 3. Therefore, Q lies on the line L. Simple as that. Next question, find the foot of perpendicular from Q to the plane P. So you have, this is no longer relevant. Let me delete it. You have a plane, you have Q here. They are interested in the foot of perpendicular. They want the coordinates of this point known as F. And if this is Q, are you able to find F, the coordinates of F? Or you can go and find OF. What is it equals to? To do that, you notice that F is just the intersection between this dotted line piercing through the plane. So if you can find the equation of line QF, we put QF into the equation of the plane, which is actually this. The plane is R dot 2, negative 1, negative 2 equals to negative 3, right? This is the equation of the plane. If we can find the equation of QF, we sub it into the equation of a plane, we should be able to find F because that is the point of intersection. So let's go ahead and find line QF. Do we have a known point? Yes, it's Q. Q would be 5, negative 1, negative 2 plus, I don't want to use lambda anymore because it's already used, so I'll use mu. Now what is a direction vector of this blue color dotted line? It's exactly the direction vector of the normal. So if you have the normal, which is here, 2, negative 1, negative 2, you can just put it inside. Then we sub this line equation. Oh, my bad. It should be like that. Right, we sub R into this R to give me 5 plus 2 mu, negative 1 minus mu, minus 2 mu, dot 2, negative 1, negative 2 equals to negative 3. 10 plus 4 mu plus 1 plus mu plus 4 mu equals to negative 3. So on the right side we get negative 18, on the left hand side we get mu, 4 mu, 9 mu, so mu is negative 2. So this means that if I sub in mu equals to negative 2 back into our QF line equation, we would get exactly the point F. So let's push this back in and we find OF is equals to 5 plus negative 4, 1. Negative 1 plus positive 2, 1. Negative 2 plus negative 2 times negative 2, 2. So the answer for OF is 112. Because it's pretty ambiguous, we don't know whether we want the coordinates or the vector OF, it's good to write 2. So you can write F is 1, 1, 2. This shows the coordinate and this shows the vector. Last part, find the vector equation of the line which is a reflection of the line L in plane P. It's a continuation of part 4. Once you've found the foot of perpendicular, so let me draw a nicer picture here. So this is point Q. We have found F, which is 1, 1, 2, and Q, which is 5, -1, -2. Part 3 says that our Q lies on the line L. It should look like that. This is line and Q lies on the line. Now if I want to reflect this about the plane, if I want to reflect this purple line about the plane, I should get this pink color line. And we would be able to find Q prime. Q prime is actually the reflection of point Q about the plane. Why we need to do this is because once we found Q, we find this one, then we can easily create the equation of the pink color line. So how do you find point Q? Just take a look at this. 5 go to 1 with -4, right? So to get to Q, we minus another 4, get -3. -1, how to get to 1? With +2. So from here to here, also same process, +2. -2, I want to get to 2, I +4. So here I +4, I get this value. So this is point Q prime, the reflection of Q. Then we need to find this particular point. To find this, just equate the purple line to the plane to find the intersection between the purple line and the plane. Purple line, R equals to 2, -1, 4, plus lambda 1, 0, -2. Plane R dot 2, -1, -2 equals to -3. Push this R into this. Same thing like we done before. 2, -1, 4 plus lambda minus 2 lambda dot 2, -1, -2 equals to -3. 4 plus 2 lambda plus 1 minus 8 plus 4 lambda equals to -3. Throw all the numbers across, I'll get 6 lambda equals to 0, lambda equals to 0. Now don't panic, lambda equals to 0 is not a big deal. Just put lambda equals to 0 back into here to find this particular point of intersection. If you put in lambda equals to 0, this point will be 2, -1, 4. 2, -1, 4. So now you have all the equipment you need to find the equation of the pink color line, which is R, one particular point, 2, -1, 4, plus, let me just use another Greek alphabet, alpha. This would be this minus this, 5, -4, -2, where alpha, it's a real number. This is the answer for the last part, equation of the line of reflection. Now the next two questions will be from the chapter of probability. First one, you have to make use of conditional probability. So let's take a look at this. John plays for his school soccer team. There's a probability of 0.15 that he scores. Probability that he scores is 0.15. Probability that his parents are present, parents present, would be 0.3. When he scores in the game, there is a probability of 0.2 that his parents are present. So in order to convert this sentence into math notation, you have to make use of conditional probability when he scores. So that means given that he scores, probability that his parents are present. So probability that parents present given that he scores is actually equal to 0.2. And this on the left side can be converted to this, right? PP and scores divided by P scores equals to 0.2. What's the probability that he scores? 0.15. So I'm going to replace this by 0.15. Cross multiply, I know that parents present and he scores is 0.03. Now show that the probability that he scores in a game given that his parents are present is 0.1. So go and find out what this is. This is P, scores, and parents present, divided by probability that parents present. So this is actually just this. You can flip this too, it doesn't matter, because score intersect PP and PP intersect score is the same thing. So I'll put 0.03 over, what is this? 0.3. Turns out, press calculator, 0.1. Shown. We're done with the first part. Now, second part, state with justification whether his parents' presence at the game will affect his chances of scoring in the game. This is, you can approach it through a logical approach or mathematical approach. Now, the logical approach is this. Is there a difference between probability that he scores and probability that he scores given that his parents are present. Now think about this in a logical way, okay? If this person's parent, if John's parents are at the sideline while he plays football, John probably will get a morale booster, right? Because, oh, my mom and dad is here to cheer for me. I should score a goal to impress them. So if this is true, this means that his parents being there affects his chance of scoring. In other words, him scoring and parents being there are not independent. Now, if it's independent, what it means is John doesn't care whether his parents are there or not. Whether or not the parents are there would not affect his chance of scoring. That would be independent. To check whether that is true, just come to your probability of scoring no matter what. Probability of scoring for him is a flat 0.15. Now, probability of him scoring when he sees his parents are there, given that his parents are there, what we found out is actually 0.1. So there is a disconnect between these two, right? If it is independent, then P scores. If independent, then P scores would be equals to P scores given that parents are there. So here, clearly they are not independent, right? Because probability of him scoring is different from probability of him scoring given that his parents are there. So you say, therefore, parents presence at game will affect scoring. Since P score is not equals to P scores given parents present. Alright? Now think about it, the opposite situation. What are independent events? If P scores versus P him scoring, given that his friend found a $10 note in his pocket. Now logically, this situation where his friend found $10 note in his pocket shouldn't affect his chance of scoring, right? I don't know what kind of universe would this affect him scoring. But this is a very obvious case of independent event, right? Because whether or not John scores is not really affected by whether or not his friend found a $10 note in his pocket, right? So in this case, they should be independent event. These two values should be the same. If this is 0.15, this would be 0.15. So that was the first approach. Now the second approach is to do this mathematically. To do this mathematically, all you need to do is make use of P A intersect B is equals to P A times PB if A and B independent. What is PA intersect B? It will be the chances of him scoring and his parents coming, right? We find out that it's actually 0.03. Now, is this equal to him scoring 0.15 multiplied by his parents coming 0.3? Turns out on the left hand side, it's not the same as the right hand side, 0.045. Therefore, A and B not independent. So here, same result. Parents' presence in the game will affect his scoring ability. So that's a lot of talking for 1 mark, but I just want to go through with you the idea of independent events, both logically and mathematically. The last part for this is actually a Venn diagram question. It is very straightforward, so let's take a look at this part. It says here, there is equal chances of it being a home or away game. So probability home is 0.5 because it's either home or away and it's equal, so 1 divided by 2. In a home game, there is a probability of 0.24 that John does not score and his parents are present. So what this means is probability that John does not score and his parents present given that it is in a home game. This is 0.24. Convert the left hand side into mathematical symbol, you'll give you this probability that S prime intersect parents present intersect home divided by probability of home is 0.24. We know this is 0.5 as we can see here. So if you were to cross multiply, PS prime PP H would be 0.12. What this means on a Venn diagram would look like that. 1, 2, 3. This is or not whether he will score. This circle depicts whether or not his parents are present. This circle depicts whether or not it is a home game. So the entire area for this one would be 0.5. The entire area for this one, whether or not he will score, is 0.15. This is whether his parents are present. This entire area is 0.3. So what we found out here, S prime intersect P, P intersect H. You got to find out which area is this. Turns out parents present, home, but not score. So it's here. This green bit is 0.12. What do they want? Find the least and greatest value of the probability that it is a home game and his parents are not present. So H intersect P prime. Which one do they want? The correct answer is they want to find out the area of this red color part. It's very hard to find out the remaining pieces. However, there's one very important piece that is vital to solving this question. It would be this blue color area you see here. Why this is important, we shall see. First of all, let us fill in this number first. From above, this is known as P intersect S, am I right? And P intersect S is here. Probability that parents present and his scores 0.03. If this piece is 0.03, you notice that there are a few ways that this 0.03 can be distributed amongst light blue and dark blue. Remember, this entire home piece is 0.5, right? My job is to find the red color piece. To find the red color piece, it will be 0.5 minus away this fixed number, 0.12, and then minus away the blue color piece. This light blue and dark blue together is 0.03. I can split it in many ways. Then the best case scenario, it will be everything will be in the dark blue. In other words, this is 0 and this is 0.03. I can also flip it around. This is 0 and this is 0.03. This will give us the maximum and the minimum value of the red color piece, because red is equals to whole thing minus away green minus away the blue. If the blue is 0.03, then that would give me a red value 0.35. And in the other situation, if your dark blue part is 0, in other words the light blue part is 0.03, then here you'll be minus the green minus away the blue, which will give you 0.38. So the minimum value of the red color piece is 0.35, maximum value 0.38. And that's the end of this weird question. Okay, last question of this practice paper, a P&C question masquerading as a probability question, because in the end you have to find a number of ways. So let's take a look. Committee decides to meet on 4 days on the span of 4 weeks for a grand total of 28 days. So find the probability that meets on 2 Tuesdays and 2 Saturdays if committee meetings are equally likely to be held on any of the days. So we have this. These are the days of the week. It doesn't matter whether you have the Tuesday and Saturday in the same week. All you need to do is choose 2 Tuesdays from here and 2 Saturdays from here. So that will give you 4 choose 2 times 4 choose 2 out of how many unrestricted ways? 28 days, choose 4 days. So the answer would be 36 over 28, choose 4, 20475. Simplifying this, 4 over 2275. 2 marks. And then the second part, it says committee meetings are held once a week now. Probability of holding a meeting on the day from Monday to Friday is 1 over 9. So your weekdays within a week, chances of each one of them happening is 1 over 9, and there is a higher chance for the weekend to happen, 2 over 9 each. So they say now meetings are only to be held once a week. So your Tuesday and Saturdays, you can't have it both on the same week. So what this means is you can either have, for example, a Tuesday, Saturday, Saturday, Tuesday combination, 2 Saturdays and 2 Tuesdays, right? You can also have Tuesday, Saturday, Tuesday, Saturday. How many of these combinations can you have? In other words, how many ways can you arrange T as ST? The correct answer is 4 factorial divided by 2 factorial, 2 factorial, right? 4 items to arrange, two of them repeated twice, times fill in the probability of this happening, this happening, this happening, and this happening. Because for this particular, let's zoom in on this, particular TSST, what is the chances of this happening? 1 over 9 times 2 over 9 times 2 over 9 times 1 over 9, right? This one, 1 over 9 times 2 over 9 times 1 over 9 times 2 over 9. You end up with the same thing. So I'm going to add this eventually, right? So how many ways can you have this? This is this. Then you want to add it up. This number of times of 1 over 9 square, 2 over 9 square, to give you the answer 8 over 2187. So that's it for part 2. Part 3, committee of 10 sits around, so 10 item, 4, 5, 6, 7, 8, 9, 10. The two committee vice heads are seated together. So these are the committee vice heads seated together, and they are not seated next to the committee head. So this is a case of people not wanting to sit next to each other. What do? You pluck these two groups out. So you have 1, 2, 3, 4, 5, 6, 7 people remaining. Then we slot them in. We slot this peach item in, and we slot this peach item in. So how many ways can you arrange 7 people first? 7 factorial over 7. Multiply by how many ways can you slot them in? There are 1, 2, 3, 4, 5, 6, 7 slots. We just need to choose 2 of them. Once you choose the 2 slots, I'm going to fit in H and this double V. We combine them, think of them as a V. How many ways can you arrange these 2 items in these 2 slots? So let's say you choose here and here. It can either be H here, V here, or H here, V here. So you need to times 2 factorial. And then once you have arranged that, you have to arrange the V within that group itself. So that's another 2 factorial. Now they ask probability, right? So you got to divide by the total unrestricted ways, which is just 10 factorial over 10. Press this in your calculator, you get 1 over 6. And then you're done with this practice paper. Thanks for tuning in. I'll do one more practice paper and I'll hopefully upload it within this week. Thank you.